Hello dear students, welcome to Axiomatikos. This video is the part of the solution series for IIT JAM 2010. So we are here with this problem 1 of your paper. This is an analysis problem. So let us firstly read this problem, what it says. Which of the following condition does not ensure the convergence of the real sequence an? So we have 4 conditions and we have to figure out a condition which does not ensure the convergence for the real sequence an. Okay, so we have to check one by one whether this condition imply convergence, whether this one imply convergence, this one. Okay, that this is the procedure. So now let me change my ink. So okay, so see what we have actually. In the A option, we have a condition that if an minus an plus 1 goes to 0 as n goes to infinity. So question says if this thing is happening, whether or not your sequence an is converging. This is what you have to check. So let me take a simple counter for this. I am taking an is equal to log n. Okay, we all know that log n is a divergent series because log infinity is infinity. So when n goes to infinity, this series goes to infinity. Okay, so this is what we know about this, that an goes to infinity as n goes to infinity. That's why I have chosen that, because in order to make a counter, what you have to do, you have to take a divergent series for which this thing is happening. Okay, now see what is this an minus an plus 1, right? So this will be what? Log of n minus log of n plus 1. So you know property of log a minus log b is what? Log a by b. So I am writing this as log n by log n plus 1, right? So just add 1 over here and subtract 1. Okay, this is the trick. So what you will end up with? You will end up with this thing, n plus 1. So now as n goes to infinity, what happens to this thing? This thing goes to what? This thing will go to log 1. Why? Because this thing will be infinity, so this thing will be 0. So log 1 we will get. Now since we are getting log 1 and we know log 1 is 0, that imply as n goes to infinity, we have an minus an plus 1 going to what? Log 1. And what is log 1? Log 1 is 0. So we have fully satisfied the condition. So we have taken a counter example which satisfies the given condition in the A option, but for this sequence an does not converge. So what will be my correct answer? A will be my correct answer, because the question is saying which of the following condition does not ensure the convergence. So I have shown that even if this thing is happening, we cannot say that an is convergent. So this is the counter that I have chosen. Okay, so now let me just mark my option as incorrect. So A is incorrect, B is correct, C is correct. Sorry, I made a mistake. I should erase it. Okay, so A is correct. Okay, this is what you have to find out. That means B, C and D are incorrect. So what is the meaning of B, C and D are incorrect? That means that these conditions will ensure that your sequence is convergent. So now the important and the informational part of the video comes. Now we have to prove that B will ensure convergence, C will ensure convergence and D will ensure convergence, right? So now let me prove them one by one here. So now let me just change ink again. Okay, so I am proving my B option. What I have to prove, that if this thing is happening, an minus an plus 1, if this thing is convergent, then I have to show that an is convergent, right? So What do you know by definition? What is the meaning of convergence of series? Okay, forgot about every test. Okay, what do you know? You know, test, many tests about the positive term series. Just keep them aside right now. Just use the basic definition for the series convergence. So what do you meaning? What do you mean by a series is convergent? So it has a simple meaning that the sequence of partial sum. Okay, what is sequence of partial sum? This is a1 minus a2 plus a2 minus a3 up to an minus an plus 1. This sequence of partial sum is convergent. Are you getting my point or not? So whenever someone says that we have a series which is convergent, okay, so what is the meaning of that? It has a simple meaning that its sequence of partial sum is convergent. Okay, you don't have to bring test here. Are you getting my point? So Sn is convergent. This series this sequence, sorry, Sn is convergent. Now we need to show An is convergent. Okay, if this thing is happening, so it is given to us that Sn is convergent. Now we need to show An is convergent. So we will use just the basic definition for the convergence of a sequence. So given any epsilon, if someone gives you epsilon greater than 0, you need to show that An actually converges. So what I am doing, I am showing that your sequence An is a Cauchy sequence. This is what I will show. What is the meaning of Cauchy? That this An minus Am, this difference, okay, this difference is less than epsilon for all n comma m greater than n naught. Are you getting my point or not? So I have to show that this difference after a certain natural number, okay, for which n and m are greater than that number, this difference is less than epsilon for every epsilon whatever you choose. Are you getting my point or not? So if you choose epsilon, you have to show that this thing is less than epsilon, and for that epsilon you should get a unique, not a unique, I will say a natural number. Are you getting my point or not? So what I will do, I will just use the property of mod here. Okay, and what is that property? That firstly what I will do, I will write an minus 1 plus an okay, I will add and subtract this thing. Now you know that mod of a plus b is less than mod a plus mod b. This is what you know. That means this thing is less than an minus 1 plus an minus 1, sorry, it should be minus am, right? So this is minus of am. Okay, just see the definition of Cauchy, okay, in your book, then you will be able to understand what I am doing. I have chosen a epsilon initially. Now I have to show that for this epsilon we will get a n naught. Now again apply this rule here. Okay, so again applying means what? I will write an minus 2 this time, right? And use that property of mod, that mod of a plus b is less than mod of what? Mod of a mod of b, right? So if you will continue apply this, so you will reach at this step an minus 1 plus an minus 1 plus sorry, it should be minus here. So what should I write? I should write, okay, this is what you will I think you will get am plus 1. Okay, this is what you will get. So finally we have reached this step. Okay, after applying the same property on this, you will reach at some point of time you will reach here. Now since you will reach here and you know that your your sequence of partial sum, okay, that is Sn, Sn is convergent, right? So what I can say from here, okay, so now try to look on this sequence of partial sum. Okay, so I should write sequence of partial sum here. What is S1? S1 is just I think A1 minus A2, right? Now what is S2? It's A1 minus A2 plus A2 minus A3. This is what your S2 is. Now S3 is what? A1 minus A2 plus A2 minus A3 plus A3 minus A4, right? So what is happening if Sn is convergent? Okay, let us say it converges to some number S. But I am saying that since it is given to us that Sn is convergent, so it will converge to some number S, right? So what is happening there? I was trying to talk about that. So see, suppose what happens that what you are doing, you are keep adding things over here. Okay, in the S1 term you have just one term. Now in the S2 thing you have added two terms. In S3 you have added three terms over here. Now in Sn you have added n terms. Now what will happen when n goes to infinity? You will be adding infinitely many terms together. Now suppose the term in the tail, what is called a tail is the last terms. Okay, so when n goes to infinity, suppose the tail is not going to 0. Okay, suppose you have a tail like this of these elements, and this tail, the sum is not going to 0, then what will happen there? This sum will keep continually, this sum will be adding continuously, and then the result will be a divergent sequence. Are you getting my point or not? So what I am trying to suggest you that what you are doing, you are adding these things. Okay, continuously adding. So the S1 term is smaller and S2 is bigger and S3 is more bigger and Sn is much bigger than that. Now if this term in the end, okay, so the sum of the terms in the end will not go to 0, then the sum will be divergent. Are you getting my point or not? So for this sequence Sn to be a convergent sequence, the tail must go to 0 here. Are you getting my point or not? So that means there will exist some natural number. There will exist some natural number after which what will happen, that the remaining sum will go to 0. Otherwise this will not be a convergent sequence. Are you getting my point or not? So what is happening here, for this n naught, okay, let me choose my n and m greater than this n naught, what I have chosen here. So for this n naught, what you have this tail. Okay, this is actually a tail if you choose your n and m to be greater than n naught. Are you getting my point or not? So this is the tail of this sequence of partial sum, and I already explained you that why tail should go to 0. Now since this is the tail, so it should go to 0 unless unless otherwise what will happen, that Sn will be a divergent series, but that's not true. So that's why for this thing, this will go to 0. That means there will exist some n naught such that an minus am will be less than this epsilon which is given to us. Are you getting my point or not? So what I have proved so far, that whatever epsilon you gave me, I can always find some n naught such that an minus am is less than epsilon. So what I have proved is that an is a Cauchy sequence. Now in the real case, Cauchy sequences are a convergent sequences, right? So Cauchy sequences are convergent. That means what we can say, that an is a convergent sequence. You got my point? So using this condition in the part B, we have proved that we can prove convergence of an. So that means B is incorrect. Okay, so now let me erase these things and we will clear up the space for the C option. Now see, in the C option, what we will be doing, in the C option, it's given to us that summation NAN is convergent. So what we will be using here, we will be using necessary and sufficient condition for the series convergent. What do you know about necessary and sufficient condition for, not sorry, necessary, only necessary condition, not sufficient, sorry. What is meant by the necessary condition for series convergent? It has a simple meaning that summation, if summation UN is convergent, then this should imply that UN goes to 0. So this is the necessary condition. It's not a sufficient that if UN goes to 0 then your series is convergent. So it's only in the one direction. Are you getting my point or not? So this is called a necessary condition for the series convergence, and I will be using this in the option C. So from here it is given to you that NAN is convergent. Using this necessary condition, what you can say? That NAN goes to 0. Right? So finally you can directly show, or you can formally also show, that why an should go to 0. You can show that limit n goes to infinity NAN, if suppose this thing is going to 0, that means limit n goes to infinity and limit n goes to infinity an is equal to 0. Now suppose this thing is not 0. Okay, suppose this thing is not 0, then this thing will be going to infinity, right? Now suppose this thing is other than a number which is other than 0, then you will not get 0 here. Are you getting my point? So this is the idea, the basic idea that I am giving you right now. You can also formally prove. It's very easy to formally prove this thing. You got my point? So therefore this is a very easy option to prove that if NAN goes to 0, then AN actually converges. You got my point? So C is also a incorrect option. So now let us introduce your D option. What it says, the sequence A2n and A2n plus 1. Okay, actually they are not sequences. They are what? They are subsequences. Okay, this is the subsequence of even, and this is the subsequence of odd for this given sequence AN, right? So what is given to you that these three subsequences converges, then does it mean that AN will converge? Okay, so it's a standard result that if subsequence of odd and subsequence of EN converges to the same limit point, okay, it's very important. The same limit point thing is very important. So if the subsequence of even and subsequence of odd converges to the same limit point, then your sequence is convergent. Okay, now it is given to you that they are convergent. It is not given to you that they are converging to the same limit point. So for that matter, what will take care of that? This thing will take care of that, that A3n is also convergent. So now let us clear the space. Okay, so now let us write what is given to you. It is given to you that A2n plus 1 and A3n, these three are the convergent. Okay, these three are the convergent sequences. Okay, I have forgotten the right word, convergent. So these three are the convergent sequences. Now what I told you earlier, that it's a very famous result that if subsequence of even and subsequence of odd converges to the same limit point, then sequence is convergent. That is, what is the note? Note is limit n goes to infinity A2n is equal to limit n goes to infinity A2n plus 1 is equal to, let us say, some L, then this will imply AN goes to L. Okay, this is the note. So you got any hint from here or not? Okay, let us use this A3n thing. What is A3n? Let us see. A3n is very simple. This contains even and odd also. So for n is equal to 1, you will get A3, then you will get A6, then you will get A9, then you will get what? A12, then you will get I think 15, right? Then you will get 18 and so on. Okay, So this is your A3n. Okay, I am going to hint you just. Okay, I'm not going to write any formal proof. It's for your intuition part. So here you see that A3, A9, A15. Okay, so you got alternative or terms of subsequence. Okay, A3, An, A15 are terms of this subsequence, and A6, A12 and A18 are terms of this subsequence. Now since they are convergent, that means this subsequence is converging to L, and this subsequence, okay, I will say they are converging to L, and let us say this subsequence converges to some L dash number. Let us say some L dash which is not equal to L. So do you think that this A3n sequence will converge then? No, it will not converge, because if it is convergent then it will have a unique limit point. So you are getting two limit points over here. That will force your L to be L dash. You got my point? So finally I have proved that L is equal to L dash. Okay, so since it's an exam question, we are not doing any formal class. So what I am doing, I am trying to hint you the proof that how it is done. Okay, you have to think it over yourself, that what I am saying. Okay, I am telling you everything what I can do, but the most important part is you have to think it yourself. Okay, I have given hint of everything what is here and what you can do. Okay, so this is how we can prove B, C, D parts. So thank you.